steer caster nose wheel, we have mechanical linkage to the rudder pedals, push-pull tube between pedal horns, and steering collar on the nose strut. Steering collar connected on the lower strut cylinder with torque links, and steerable tail wheel. Okay, what is a castering nose wheel? A shopping cart. Okay, in aviation world, what's a castering nose wheel? An aircraft with a castering nose wheel. Cirrus. Okay. Diamond. Okay. What does that mean? Just sits out there. There's no direct steering to it. Okay. So airplane comes down, and what's the goal here? How does the nose tire know to go straight? Hopefully the airflow, right? So as soon as the idea is as soon as it touches, hopefully it will straighten out. Now we do use sometimes shimmy dampeners to hold it in place a little bit, but some of those like a Cirrus and others, you'll get a slight movement to it. Okay, Grumman, quite a bit movement. And so how do they actually steer? Well, you control close to the ground with the rudder pedals, but braking, be able to turn it. All right. So high power means worn brakes. Okay, they're going to wear brakes quicker. Mechanical linkage. So we have mechanical linkage to the rudder pedals. Green aircraft with mechanical linkage. Yeah, you got a steering collar on that one. Apache, okay. Apache. The 414 has a pair of cables as well as a spring, one giant spring up there to give tension to the pilot to help them turn. Okay.
Air tubes got
Okay. So they don't use the pedals; they actually use the yoke to steer that one. Okay. And then here on the bottom end, we have a steerable collar connected. Okay, Trevor, go ahead, tell us. 172, 182. Okay, we use something like this, steering collar to push-pull tubes. And these are pretty archaic, but they still work phenomenally. So how does this actually work? So at the bottom of the nose of the 172, these come out of the cockpit from the back of the pedal. Here is a little ball end, connects at the pedals. A little rod comes in. And then the goal is to pull this until it hits. Boom. All right? And then on the collar, what do we have? On the say what? Eye bolts, okay? You have these two little rod end eye bolts, okay? And it says about 1.5 inches out. I think 172 says 1.5 inches out. Something like that you'll measure of thread. So you turn it to 1.5 inches out, and then the goal is to pull that tight. Okay? So you pull that tight, put a bolt through it, castellate a nut, and a cotter pin. And then as you push, what happens? This comes in, okay, it gives you a little resistance, and the other side will come out as you're pushing the pedals back and forth. Over time, these will begin to wear out where the spring, you can pull on it, and if you can pull on it and the spring is weak, very, very weak, and it's not a lot of tension like that, then more than likely they're worn out. Okay? They will get bent over time, but all it is a giant spring inside. That's it. Okay? The fun part is this has to be safety wired underneath the floorboard. Okay? So it just has a Phillips, or you can use a flat blade. Put them in, tighten it down, and then you safety wire the end. Okay? A little bit tricky back here. And then, last but not least, I have a picture of our steerable nose wheel. Okay? Here's our rod ends coming in, underneath the floor from the pedals, and then our connection here. Okay? This is a type of push-pull tube, spring-loaded push-pull tube, yeah? there's a picture of yours truly. Beautiful, isn't it? Okay. All right. Mechanics, anybody see a problem? Anybody see a problem here? And if you're working on the nose strut, you are liable to tell the aircraft owner if you see something dangerous. Anybody see anything dangerous besides? Okay, you see some rust? Anything else? Strut's flat. Okay, good. Any other unsafe? Okay, good. Kevlar. It's Kevlar. Right here we have a Kevlar boot. Okay? And this one you do have to tell the aircraft owner. You're under there and you're airing your tire up just quickly. They'll call you, hey, you're airing the tire up before they go out for a flight. Because most of them don't have air compressors in their hangars. So you run over, put a little air in their tires. They're getting ready to take off, and all of a sudden you see a boot like that. You have to tell them. Okay? And Joey said, tell us why, Joey. Leading cause of carbon monoxide. Yep.
Is it up to the pilot then, whether they want to actually have it fixed, or?
Oh yeah, yeah. It's their job to maintain the aircraft, right?
Yep.
But if I see something that is unsafe, what do I have to do? I have to tell them, hey, I was airing your tire and I saw that the boots around the push-pull tube is busted. And it's a very dangerous situation. The DME that was here yesterday, Dwayne, he tells a story, or he told a story to me some time ago. I don't think he'll mind me telling you this. They flew up to Canada. Okay? I know, people fly out there still. So, he flew up to Canada, and they stopped off. He flew in. They were doing the checks on the aircraft, what's that called, like in the customs border, yeah. So they were doing the check on the plane, and he was like, well, we gotta get some snacks. So they went in to buy snacks, and ends up buying like all these candy bars and like potato chips, and so like the next morning, he wakes up, and he's like, why did I buy all this stuff? Like, he didn't buy any breakfast food or nothing else. Totally unlike it. Lo and behold, goes out to the plane and realizes that the steering boots were all busted, and he had been just smelling carbon monoxide the whole time. So he was super loopy. Thankfully, he didn't go to sleep permanently. So they're riveted in here through the floor, and it's not uncommon to see people duct tape them. Okay, you as mechanics, will you duct tape them? No. You'll tell them, hey, you need to replace those. They're like $250, so a lot of times people are like, I don't really want to spend that on a stupid boot right now. $250 is really, really cheap when you talk about going to sleep while you're flying and not waking up. Okay? All right, here's a little closer look. It is super common. I had a student last year, same thing. Hopped down underneath it, was working on his 182, and I was like, dude, what in the world? You can't fly like this. And he was an instrument pilot. No, man, you can't fly like this at all. Not a chance. So, change them out, pop them out. I think he found his for $150 a piece. We were able to install them. Okay? And he had already had sheet metal class, so he went through and popped them all out. We got new ones in. Okay, another closer look at it. Literally, it just rides in there, back and forth, that push-pull tube. Any questions? Yeah. Ooh, good question. So, do you care if I draw a picture? Now, it's not going to be perfect. Sorry. Okay, so the boot should come down like this here. And then it has a little, like a little collar here, okay? Okay, it's all soft, but it's Kevlar, so it's not real soft. It's kind of, like when you squeeze it, it's not like squishy at all, okay? So it's like a hard fabric. at the end, it'll have like a little bitty collar around it. And so it rides down about this far, okay? About halfway or so, okay? And so it's missing more than just a little, okay? And over time, what happens is because the aircraft's vibrating and the exhaust is right above it, that's why people go to sleep, because the exhaust is coming out right up, literally right here. Exhaust comes out right there, so that's where it goes, and so that's why it becomes so brittle. Okay, flat Kevlar. Any other questions, comments? Good question.
So, does that like make it unairworthy though?
Oh yeah.
So then, how are you able like to sign it? Well, I guess you would sign off on what you put in as a prior, but would you still sign that off? Like, say, even though you let the guy know that your plane is unairworthy?
I told him, this is an unsafe condition. You need to know that this is an unsafe condition. For your health and for your safety, I have to tell you that I have seen that your boots are busted. Does the aircraft owner have to fix it? No. I've told them. I've done my due diligence and told them, hey, your aircraft is going to put carbon monoxide right inside the cockpit. You need to know that. Now, if they hop in the plane and take off, who's it on? No, on them. Okay? If we had the situation with a guy who didn't want, who were like, well, we don't want to pay. You know, you're going to face that someday if you're in a shop. Oh man, no, I can get it done cheaper. No problem. Aircraft is out of annual. What do? You put the aircraft back together, slide it outside. Owner operator shows up out of annual, flies it to another field without a ferry permit. Who's it on? Say what?
What's their fault?
It's on them. So how do we sign the logbooks? Opened the aircraft, inspected it, closed up aircraft for at the owner operator's request. Are you serious? That's all we can do? Yep. They hop in it, it's out of annual, it's on them. Because they didn't want to fix it. It's going to happen at some point, okay? Do I want them to take off like this? No. But, man, I got to tell them. Okay? It's on them. But it is, I thought nothing of it as a kid. But after reading the amount of people that have gone to sleep in Cessnas, and not woken up or waking up as they get closer to the ground. Those boots, they matter, okay? And it just has a little bitty lock ring around the top of it like that, okay? Okay, differential braking. Yeah. Get a video this morning to get Josh awake, okay? Josh, you good? just the man. I'm sure they, after flying that many times, they figured something out. Plus, it was already warm. Okay, large aircraft. How do we steer large aircraft? Most use hydraulic power. Can you imagine having direct linkage to a 747 coming down? It's like, push on the pedal! You know, you're hammering on the pedal and trying to get it to turn. That just doesn't work in large aircraft at 520,000 pounds. Okay? They're controlled from the flight deck. So they'll use hydraulic pressure. More than likely, they'll use what? Hydraulic what? Booster or actuators, right? Actuators to be able to actuate the landing gear. On the flight deck, they'll use a small wheel called a tiller. A tiller, okay, tiller wheel. Because the rudder pedals only steer it usually about 7 degrees each side, so 14 to 18 degrees here to here, okay? That's usually about all you get from the rudder pedals. So when they're out on the runway and they have to make a huge turn, they'll use something called a tiller wheel. Okay, I have a video to show you how a tiller wheel works. Okay, aircrafts with joysticks. What's an aircraft with a joystick? Airbus. Cirrus uses a joystick over here, but it's for as a yoke. But a lot of aircraft are going to use a joystick. Okay, almost like video games. The way they control with a tiller wheel is sometimes mechanical. They will use cables on down to a hydraulic actuator. Sometimes it's an electrical signal like the 787. They'll just send an electrical signal back and forth. Our cars now, is it the gas pedal, is it actually a cable anymore? No, it's just like throttle position sensor that always goes bad, right? They're even doing that in big trucks, the larger trucks. Just a little bitty rheostat. As you push it, it reads the amount of ohms going through it. It's like, oh, or voltage, I guess, right? The amount of voltage, what the ohms. The amount of voltage to it. And controlling how fast the throttle goes, so it's all electrically done. Or hydraulics transmit movement to a steering control unit. Down below, I have a picture, and there's one in your book on one that's hydraulically controlled. This hydraulic metering valve directs pressure to an actuator, then rotates the nose strut back and forth. Accumulator or relief valve allow the actuators to also serve as shimmy dampener or steering dampener. Okay? What's another word for an accumulator? What does accumulator do? Stores pressure. It's also called a surge protector, right? Surge protector in case we get an initial surge in the system. Accumulators also acts as a surge protector, okay? Because it's got a little bit of buffer in there with the pressure. Okay, but what's the importance of an accumulator for steering? Maybe, but it gives you a quick initial push. Okay, so let's look at a 747. Double-decker 747. Where's your engine? Way out here on the wing, okay? But I need to steer right now, okay? Maybe the engines are just idling. Well, maybe you won't have the boost that you need immediately, so the accumulator will give you the boost to be able to steer instantaneous, so the system will keep building, okay? So you get an initial quick boost if you're needing to steer out onto the runway, okay? Some aircraft use rudder pedals for small turns, as I already said this. Your rudder pedals really do just a limited amount. Now, what's the importance of that? What do you think, Zach? Why would they only do a limited 15 or 18 degrees at the rudder pedals on large aircraft?
Didn't you say something a little while ago
came apart. Yeah, okay. It is vaguely coming back to me, yeah. But why? So it, okay.
That's just what I remember.
So why would we only want about 15 degrees and not full travel like we do on smaller aircraft?
If you're joining for a landing and you have to grab or you can't
Rudder be 45 here. Nose will be 45.
Yes, you want the control from your rudder, but you don't want that control at your nose wheel, okay? Because unlike the Cessna Skyhawks, they're not meant to side load an Airbus, okay, or a Boeing. Oh man, I side loaded it at 400,000 pounds on one strut. Kaboom! Okay, it's not meant to side load it. And now I know if you get on YouTube and you look at what do they say, the 100 most craziest landings, pretty severe side load on some of those videos.
Thing that happened yesterday. Yeah, Scott Sutters and all this truck came apart, like Lear, and it crashed into a G200 and killed somebody. Like off the runway. You didn't hear about that yesterday, and the truck sitting on the runway?
No. Wow. So safety valve relieves pressure so the nose wheel can swivel in a hydraulic failure, okay? Oh no, we've lost hydraulic pressure. So then some systems, sometimes they will become, there's actually two different safeties. Sometimes the aircraft will become a differential braking. Now, I'm using differential braking to control this nose wheel. And then sometimes they'll have an emergency accumulator right at the nose gear, okay? Like you would for a landing gear in the back, you also have one at the nose gear, so that way you get a little bit more pressure in the event, and it will shut down. Okay, now I'm in emergency mode. I've lost pressure from the hydraulic pump, okay? Maybe you get a line, maybe somebody cross-threaded it, right? Elijah's a little bit salty about that. They've cross-threaded a fitting, and then all of a sudden a vibration and the line starts losing pressure. Okay, the system says, oh no, I'm losing pressure. It automatically shuts off and says, we'll use the accumulator in emergency mode so that we can steer the aircraft, okay? Pretty cool. There is your fancy tiller wheel. Tiller wheel, okay, over here on the left. Usually by the pilot's left knee, okay? Some of the more sophisticated aircraft will have them on both sides. This is the one from your book that it gives you. So there's your tiller wheel, okay? And you've got an emergency release. That way you don't incidentally, oh no, I hit it while we're going down the runway. So you'll hit the button. You can hit the tiller wheel release button to be able to take over the steering of it. Comes down to a series of pulleys, okay? And then down to your actuators. All right. Yes. So we're going to watch how they do it on the ground.
If you were diagnosed with kidney, testicular, liver, or thyroid cancer, or ulcerative colitis, PFAS can
Hi everybody, very welcome to Mentor and yet another video podcast. As always, I hope you're doing absolutely fantastic. So guys, very welcome to the office. I have a couple of minutes here just to show you a little bit around in the flight deck. And today on the podcast, we're going to talk about how do aircraft move around? How do we maneuver the 737? Do we use a steering wheel? Do we use rudder pedals? What do we actually do? So stay tuned. Right guys, so how to maneuver an aircraft on the ground might sound obvious, but if you don't know how this actually works, it might come as a little bit of a surprise to you. Okay, first of all, when it comes to reversing the aircraft, you know, when you're in at the gate, all the passengers are seated, everything is closed up and the aircraft starts moving backwards. Well, the aircraft cannot do that by itself. We have no kind of engines connected to our wheels. We only have our engines that are pushing us forward, and even though we have reverse thrust available, we're not allowed to use reverse thrust to actually reverse the aircraft. Okay, so in order for us to move out and away from the gate, we have to connect something called a pushback truck. A pushback truck effectively just either connects to the nose gear or actually lifts up the whole aircraft with the nose gear and then starts pushing the aircraft backwards. Obviously, we need to be in contact with air traffic control. We need to have clearance from the control tower before we start doing this. So normally, me and my colleague, my first officer, would call for push and start clearance. When we've received that, I will be talking to the ground controller, which is a person on the ground who might be sitting in the pushback truck or walking next to the aircraft. So I'll be talking to them, asking them if everything is clear around the aircraft, so there's no one behind us, because obviously I can't see that, that no one is moving around the engines. And if they confirm that, they will also confirm that all the doors and hatches are closed and all the external checks are complete. When they've done so, I am going to tell them that we've been clear push and start, that the parking brake is set, which it is here. Okay, it's not illuminated now because the simulator is in freeze, but I'll show you how to release it in a second. All right, so when we've been clear push and start, we will then be pushed back by that pushback truck that I was talking about before, and the ground personnel is going to tell us when we can start engine number 2 and 1. Now, if you want to see how to start the engines, I did a separate video on that. I'll link to it up here, that you can see how we actually do when we start the engines. And also, if you want to see the whole procedure, if you go into the Mentor Aviation app and you get the collection full setup from dark to taxi, you will be able to see how we do all of this. But I'll show you a little bit about it now. Okay, cool. So now, in the position we are right now, we have already been pushed back. The engines are already operating. So from now on, it's about taxi the aircraft. Okay. Now, in order to taxi the aircraft, we can actually use the rudder pedals. Okay. The rudder pedals will give us about 7 degrees of nose wheel steering. So if we move the pedals like this, that will actually help us turn the aircraft. However, when we're taxiing on the apron like this, or for lining up on the runway, we need to be able to be much more maneuverable. Okay, we need to be able to take much greater angles of turns, and the way we do that is by using this. Okay, I'll show you here in a second. It's what we call a tiller. If we move over here, you'll see what I speak about. It's this one. This here is a tiller. Okay, that one can be moved full left and full right, and this is essentially a steering wheel. Okay, so what we're going to do now is we are going to start to taxi the aircraft a little bit. I'll show you how to do that. We'll see if we can get the camera standing in a good place. So the first thing we need to do is we need to get taxi clearance. So we will call air traffic control, ask them if we can taxi. The air traffic control will say yes, taxi, and they will give us a specific taxi route. So we will be checking our plates. I'll show you an example of the plate here. We'll check the plate. Me and the first officer will discuss, make sure that we're both happy with how the taxi routing looks. So it's like straight ahead, first to the right, and then straight ahead a little bit more, and then we'll be following that taxi route in our plate as we taxi. It's really, really important, guys, that you do not taxi unless you're absolutely sure where you are. Because if you're in a complex airport like we are right now in Dublin, you might be taxiing the wrong way, and you might actually be accidentally entering a runway, and that could have potentially disastrous effects. Okay, so it's really important that you do not taxi without being absolutely sure about your taxi clearance. Okay, good. Now, in order to start taxi, we need to unfreeze this.
Oh no, 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 they're implementing another work platform.
Okay guys, so in order to start taxiing the aircraft, we need to start by releasing the parking brake. Okay, so put myself into position here, And what you do is you use the tip of your toes, the toe brakes, push them down. That then releases the parking brake, and the aircraft is now without brakes. Okay. The next thing that we do is we're going to add thrust. Now, in order to get breakaway thrust, you need about 30-32%, depending a little bit on how heavy the aircraft is. But, you know, something around 30, 33, up to a maximum of 40%. As you can see here, the ground speed is now starting to move. And in order to taxi, I will be using my left hand. And I'll just show you here how it looks. As I'm turning my left hand, the aircraft is turning. Like this. And we're trying to follow these yellow lines that you can see here. Okay? So we're following the yellow line here towards wherever we're going. If I want to brake, I'm using the tip of my toes to brake. As you can see, we're slowing down, and obviously that is together with reducing thrust as well. So here we're coming up to a stand. And if I want to stop the aircraft, I should probably make this very obvious to you guys that I'm sitting in a simulator right now, so I'm not actually taxiing around wildly in Dublin Airport. So if I want to stop now, once again, I press the toe brakes, put the parking brake on, and release, and the parking brake is set. Okay? I hope this all makes sense to you guys. Now, there's a couple of maximum speeds that we have to keep to. We have to keep a maximum of 10 knots around turns. If we're on a straight line off a runway, the maximum speed is 30 knots for us. And if we're backtracking a runway, we can go as fast as 50 knots. If we have contamination, so if it's snow or ice or anything on the apron, in that case we limit our taxi speed to 5 knots, right, which is really, really slow. So once again, we have the tiller, we have the rudder pedals, we have the toe brakes on the rudder pedals, and that is pretty much how we do this. So if I want to taxi in.
Alright, any questions? We good? How many of you guys knew about the tiller wheel before? Alright, so I used to think they would use just a rudder pedal. But no, it's an extra degree of safety that they have. They're out there on the runway. Being able just to only have 7 degrees each side up for the nose roll. Alright, you guys take a break. Come back about, let's do 10 after, okay? 8:10. So a typical steering hydraulic system would have, you have hydraulic pressure, system pressure, then you have metering valve so that you're not actually sending 1,500 or 3,000 PSI to the actuators at the front. What's another word that we would use on like the brakes? A debooster, okay, so kind of acting like a debooster, but more like a orifice, right? And an oleo strut to limit it, okay? So then it comes through there, metering, you have port A, port B. And then we have an emergency bypass in the event that we lose hydraulic pressure, okay? Or one side can get clogged, right? There's a look up and close to the actuators. Sir? No. Anyway. Look a lot, besides being super fancy. Oleo strut, all that looks a lot like our smaller general aviation, just at a higher cost, right? What are these? Ooh, let's ask Parker. Parker, what are these thingies on this tire? Ooh, it's a good written question. Huh? Throw the water off is a good written question. What are they called? Chines. Chines. Okay? Yeah, they deflect water. a direct linkage right to the tail wheel. Okay? In this case, it doesn't. It's just kind of a bit spring-loaded. What's it connected to? The rudder. Okay? So you're controlling the rudder. Okay? And then sometimes the Scots are spring-loaded back and forth so that if you overcorrect, it will hit a stop. Okay? And the way the tail wheels are created or designed is that as they get over a certain point, okay, so say you need to make a quick turnaround, 180, once they get to a certain point, they will pop over a stop, okay, and then they become what we call free spooling. Free spooling. So they will actually spin all the way around, and you do that with your brakes. So you get to a point, okay, I can't get any more, and you hold the brake, and they'll start to roll. They will pop over and start to free spool, okay? And so one of the things that during a 100-hour inspection or during any inspection on the linkages, you will check for that stop. You'll turn it, put pressure on it as you have pressure, and make sure it stops, and then roll it around, okay? Back and forth. Make sense? All right, that's a typical check that we would do. What about this one? Whoa, what you got here? Little ski. Pretty gnarly, isn't it? What's right above it there? What's that thingy up here? Say what? Up here is like almost like a strut or this is acting as a shimmy dampener here. Right? What's the shimmy dampener do? Thank you. What does that mean in elementary terms?
It reduces the amount of like vibration.
Vibration or oscillations. Good. All right. And so here, it could be a retractable, could be acting as a retractable, but it's obviously got a nitrogen charge on it. Ooh, is it safety wire? I think so. Okay. All right, here's typical shimmy damper. Okay, inside, this is super, super basic. You understand oleo strut? There it is. That's all it is to it. Okay, you have a tiny little piston, which is supposed to move inside and out. You have O-rings on either end to prevent fluid from leaking. Okay, and between here are two little tiny holes inside the piston. And so what happens is it'll move fluid on either side. Okay, so hook to the steering linkage. You're hooked to the steering linkage here, one bolt here, to the collar. And so because you have fluid on both sides of the piston, it prevents it from moving quickly. And so as it turns, it forces fluid through the orifice. What's it sound like? An oleo strut. Good. All right. So it just slows the way it moves. Doesn't stop it. Just forces the fluid through the two little orifices. Okay. Then this is a filler hole. Most do not use filler holes anymore. Most will have to fill it through this little bottom here. So pull it back, and it will slightly go back down into the hole. I'm dead serious. When the new one will go slightly down into the hole, and you just keep filling, or you stick it down into a can of hydraulic fluid. Once you've got it pretty close to full, and then you stick it in and you pull it back and forth. What am I doing? I'm burping the baby, right? You're burping the baby. You put it down in the fluid. Once you get almost full, shove it all the way down to hydraulic fluid. And you're just going to move it back and forth until the whole cylinder is full of fluid. Okay? And you want to get all the air out. And you can actually hear the air when you push it through. Okay? A little bit of air is okay. pocket in there, and what will happen is all of a sudden you get this movement, and it gets real soft. And then it'll get hard again until the air gets right to the orifice, and then okay. So one of our shimmy dampener inspections is more of a visual. Okay, does it leak? Some of them use grease. Some of the shimmy dampeners use grease. Why would they use grease? It doesn't leak usually as fast. Okay, but the problem with grease versus 5606. Stiff. Viscosity. If you go up really, really high, okay? Now I'm taking off at a whopping elevation of Ionia, Michigan, which is what, 700 feet or something? And I'm going to fly to Colorado. Land at Denver at 5,000 feet. If it's grease, it might get a little thicker, okay? All right, any questions? Everybody? Yes, sir.
Would grease be something that they use more on like heavier aircraft than you're not going to use on smaller aircraft?
Well, let's say mid-size aircraft, okay? Because once we get to like Gulfstream and Learjets, they're using actuators, you know, and they're going to have the little surge, or what we would call a accumulator tank, very much like that with a nitrogen charge to prevent that movement, okay? All right. So this is, this one also has a filler cap, but a lot of our newer ones, so there's a company, and now I don't like the name of the company, but they make really good products. It's called Lord, L-O-R-D, Lord, okay? They make shimmy dampeners that are sealed, okay? And so say Brian wants to put one on his 172. Do you have a shimmy dampener on your 172? Okay, so originally a lot of the aircraft didn't come with shimmy dampers. And so you would buy it from Aircraft Spruce, you'd buy a Lord or McFarland, whatever. That was going to come with the STC. Oh, you just shove it on there. They're not outrageous, pretty affordable. And it is a direct connection, and then you put the 8130 with the STC. Make note in the logbook. Please see or install this Lord shimmy dampener in accordance with this STC. C attached 8130. You stick that in the back of the logbook. And then that Lord shimmy dampener, there's no opening it. It's sealed. So the moment it dies, you just buy another one. You already have the STC. Okay? And that's pretty common what a lot of people are going to now, because it's just remove and replace. Like the automotive world. Yeah.
What happens when it dies?
I'll show you right now. Yeah. All right. Sydney, let's answer your question. What do the boots are supposed to look like? See the boots? Oh, come on, Sydney, you're killing me. Can you see them now? Yeah. See the boot coming all the way down? And then it's sealed up. These are latest and greatest, okay? All right, so you see what a boot's supposed to look like, how long it is? Dan, are you interrupting me? No. Okay, good. All right, so not a giant hole here, comes down, and then there's a little clamp right here on the push-pull tube. Okay. mechanic hats. So Parker asked the question, Parker answered the first question. So what's the problem with, or how did you know the shimmy damper, even though it's attached, was bad? It's true. If the pilot comes in, does the pilot know the shimmy damper is bad?
Yep.
No idea. We're talking about pilots. No. No, they don't know it's bad because they're in the cockpit. They can't see it. And what would they say? Man, I have a vibration. I think one of the tires is bad, right? That's the first thing you're gonna say. All right? They're not. Trust me, they're not. You might.
What happened to me? I know what it was.
You got a mechanic hat on now, homie. All right? But now we're talking about pilots here. And so they've got a pretty severe shimmy. Okay? They're going to say, I've got a vibration. What's the next thing? Wear. Good. Tire wear. But what's really taking the views right now? Oh, that's hilarious. Wear. Tire wear. Good. But tire wear, but what's actually wearing in this scenario? Bearings. Bearings are screaming. And so a shimmy damper is actually a very valuable tool to prevent wear of your bearings and the tire. The axle, that one little axle bolt is screaming, man, when we're doing this landing and takeoff here. Okay? Yes, sir?
What's that shimmy damper actually? What goes bad with it actually?
Fluid leaking out. Usually leaking out on this end, on the back end. And it's, you'll see a little sticky spot. Start to see a sticky spot on the end where the shaft comes out. Pretty common. And you'll be able to move it when you grab the shimmy damper and you start pushing it, you'll feel a little air pocket in there. Okay? Or with a tow bar, start moving it, and then all of a sudden, as you turn it back and forth, you'll feel a little soft spot, and you know it's got air in it. Okay? You can refill it unless it's a sealed one. You can refill it through the end if you pull it back, or if it has a filler cap. Okay?
You only change these when they go bad? Sealed?
Yeah, and then we do have the opportunity to change the O-rings in those as well. Especially all the ones that we have in our shop, you can change the O-rings in them, okay? And so you'll have you'll have several O-rings. You have one around the little shaft, as well as one around the main end there, okay? All those O-rings can be changed.
So there's no way to really prevent it, you just have to
Yeah. Yeah, and you know, during inspection, if you turn it back and forth and you feel there's a little air in there, oh, okay. Why does it have air? It's obviously gonna have to leak out at some point. Yeah. But the nice thing with 5606 is it leaves a sticky residue. Usually, if you feel a little residue, stickiness around that, that's a good dead giveaway that it may have already started leaking. And they're always exposed. The shimmy dampers are exposed to the elements. So it's common. It's a common failure. Those of you who installed your oleo struts, what's the problem that you have seen it smacked with torquing the shimmy dampeners on? Oh, yeah, on the nose, huh? What's the problem if we do though? Oh, it's gonna destroy the collar. Okay, so it's got to be able to move. You got to have a little bit of movement on the shimmy damper. Okay, the bolt itself got to move. If you torque it, the one that normally breaks is the steering collar, the collar itself, which means the whole oleo strut's coming off. Okay, so please be mindful of that. You don't want to torque it down. All right, let's do it one more time, huh?
It's a direct linkage to the rudder pedals, right?
It is,
So
but
would
just
the
remember
pilot do
that
that?
it's spring-loaded, so
Oh, okay.
you've got a little bit of dampering there, but man, shimmy dampener really does save the axle, the bearings, and the cup, all that within the wheel. Just a few times, yes, we don't have to use it very much, but you can see one takeoff, one landing, just how severe it was. Yes, sir?
How much does like this one cost?
Somebody get on Spruce, look at Cessna 172 shimmy dampener or McFarlane, either one.
So if you have someone who says that their shimmy dampener is bad, or you find out someone's shimmy dampener is bad, you know, also want to look at the tire, check the bearings and
Yeah, yeah.
Lord, one aircraft cruise is $1,300.
$1,300 probably comes with STC, or is it just outright? Hey, what's the tire cost you? What's the tire cost you? $300? What's the tube cost you? $200? What's it gonna cost me to change them? $100? Okay, I'm at $600. You could do that every few months. If I gotta push a cup out every few months, bearings, oh, you're gonna be $1,400 in just a few flights. So, I think the shimmy damper's probably worth it. All right. Just a regular Cessna shimmy dampener, what's it run? 800 to 900. The nice thing with the Lord is they're sealed.
Well, the Ford one says unique rubber formulation with high-tech lubrication.
They don't tell you what they put in it yet.
There's no fluid.
It's probably a grease style. Sometimes, hey, there are some that have used nitrogen in the past. But then you know when they're bad for sure. Yep, it's gone. Nitrogen's all gone. Okay, there you go. I already had a picture for you. Lord me. Okay. Uses surface effect dampening. In place of metal piston, a rubber piston presses out against the inner diameter, coated with a very thin film of grease. Ooh, like I've already said that. I kind of jumped ahead of myself, sorry. Materials used provide a long service life without ever needing to add fluid to the unit. Kind of nice, but they don't fail too often. Okay. Anybody else? Questions, comments? I couldn't honestly see why a flight school wouldn't want one. You know, you're buying soft tires already. All right, switch gears. Let's go to aircraft wheel alignment. Couple more videos to keep you engaged. Oh, you can't see what I see. Sorry. Okay, aircraft wheel alignment. Aligning the wheels, the main wheels, okay? We have, this is a, ooh, let's see, who can guess this type of aircraft? Oh, I already gave it away. Stink! All right, it's one of my favorite songs. Okay, so crosswind landing gear actually comes out.
Is it supposed to be like that?
Yep, called a crosswind landing gear. I've worked on just a few of them. Not enough to be pro on it, but enough to know that you better take it seriously. Okay, so here's your axle for a typical Cessna. Okay, everybody with me? Okay, if you're wondering where I'm at, this is what goes onto the strut. This is where the wheel goes. Everybody with me so far? Okay. So what they did on the crosswind is they put a pivot point right here, and so it can actually turn, brakes and all. And so it was super cool because the aircraft could come down in a crosswind and the tires would be straight down the runway. And so they called it a crosswind. There's also a great problem with it. Huh?
Ground operation?
Ground operations, yes, but if one was gummed up and you come to touchdown and it did not straighten up, it would roll the tire and the wheel immediately. Okay, so I'll roll it back real quick. I quit saying. I've heard instructors say this, and I'm not bashing anyone like that. It's like, well, you won't see those anymore. Okay, because you know how many. I wish I could show you the text on my old phone of how many times they were like, "Guess what I'm working on today?" You know, somebody sent me just the other week a Franklin engine. Well, a Franklin engine would have been early 40s or late 30s. And he sent me this picture and he's like, what do I do here? I've only read them in books. You know, I worked on them probably when I was 14. You know, it's over 20 years ago.
Gotta keep the bloodline. There's one extra seat. That's not
That's a crosswind landing gear, okay? So highly sophisticated, but you might have an opportunity to see those. At that point, okay, all those need to be well lubed. The axle itself, but the pivot point, okay? That way we don't lose it. You don't want it to crack, you want to be able to pivot as needed. Okay, other points, so gear with struts. Gear with struts. We have shimmy dampener, we have torque links. So say you're working on, hey Corbin, is this a nose wheel or main wheel? Why would you think it's a nose wheel? Shimmy dampener. Is it retractable or non-retractable? Come on, Joey, go with your gut. Retractable. Why would you say it's retractable? Is that what you said? Good. Good. Thing in the front. All right, let's use, adult terminology. It's got some linkage. Good. Spring thing there. Little spring thing, right? All right. We also have the over center bar. Okay. Guess what the over center bar means? It's over center. Good. So instead of directly coming down, it's slightly over center to hold the gear in place for those brutal landings. Okay. All right. So how do you adjust? I think Parker and Anthony. How do you adjust the direction on a torque link style landing gear? Parker, how do you adjust it? You're going to place your washers here in the center, possibly here, like on a Piper, right? You have the big honking washers. And some of you had even asked me, what side do I put the washers? Well, it depends on the alignment. The alignment of the wheel. So what we do is you can take a board and set the board out in front of the two main wheels all the way across. Okay? And you can set them on jack stands. And then you can use a square from the board. Now you want the board to be fairly straight. And you're going to check it at a 90 degree for toe in or toe out. Okay? Womp, 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 womp. All right, what is Ryan saying? So you got your aircraft here. Okay. All right. So here's our wheel, and right here's our wheel. Okay. You can set a board across these two. Okay. Set a board in front of the two wheels, right at the front, and usually about halfway up the tire. Okay. Put the stuff in case of spot. sitting there, you have the tire, and you want to put the board somewhere across midway, okay? Why don't we use a string? Because it could potentially give a little bit, okay? The nice thing with getting jack stands, like automotive jack stands or whatever, and just getting it up high enough mid-wheel, is you can put a 90 across it, okay? And that's going to tell me what? If I put a 90-degree bar across it, it's going to tell me how much is facing in or facing out. Every aircraft is slightly different how we adjust toe in and toe out, okay? So, for example, on a Cherokee, you will use those little cute shims on the torque links, or you'll use a larger shims on the upper and lower torque link. Down here, okay, you may have the upper or lower shims, and so you may have, oh man, you may have 2 shims on one side and none on the other, okay? We had an aircraft come in of a former student from here. He's working at Grand Rapids. He just bought a Comanche. When it came in, we looked at it, you know, from the 20 feet away, and noticed that one of the tires was like this, facing way toe out, okay? So the aircraft nose was headed this way, and it was facing way out. And they had put the shims on actually on the outside to push that torque link way over on the back. And so all we did was move the the shims on the torque link over to the other side. And I think what happened was they just got confused and put the shims on the wrong side. And the moment it started going down the runway, what happened? Just pulled that tire on out. And so it became stationary there. Okay. Now, remember on the Cessnas, they're all going to move a little bit. What's a contributing factor with the way the aircraft sits? What are some contributing factors? Go back to weight and balance. What are some contributing factors with the way the aircraft sits? How much weight? What could be a huge added amount of weight? Fuel. Somebody said it? Who said that? Fuel. What else? Passengers. Okay, they're not necessarily in there yet, but fuel is a big part of it. Anything else? Ballast. Good. What if we just had the aircraft jacked up and then we just set it back down? Is that its normal setting? No. When you lift a Cessna up, what happens the moment you put it back down? The tires are sitting like this until you begin to pull it straight. Usually, if you're going to adjust wheel in or wheel out, you want to pull the aircraft from here to the back of the room minimum before you measure it. Why is that, Micah? Why would I want to pull an aircraft, what is that, 20 feet? Not even 20 feet, 15 feet?
Has something to do with rotating the tires all the times that put it on shims.
Good. You want to move it in the normal direction. Because think about it, when you go to pull an aircraft in the hangar, what's the direction we normally get the aircraft in the hangar? Push it back. Aircraft doesn't normally go backwards. Okay, I know he said we don't move jets backwards, but I've watched lots of shops back King Airs into shops. They'll put them in reverse thrust and back them in. Pretty cool, but tires don't normally go in that direction. Okay, so that's why we're pulling it. We want to pull it in its normal direction so we can get a true measurement. Now, just to make you guys feel so happy, here's the Cessna style. And this is shims that we have. These are true Cessna shims. And I'm going to pass quite a few of them around. But the goal of this is to frustrate you. Okay? Not my goal. This is Cessna's goal. So these are shims that you would put on the axle like this. Okay? So you measure it, and this adjusts toe in, toe out, and camber up and down. But one size does not fit all. And Cessna even says in the very smallest notes at the bottom of a page that you will never get it true. So if you measure it and it's true, pat yourself on the back. That's the last time you're going to see it. okay? Because the way they make these shims is it's a guessing game. Well, maybe it needs to go this way. So if I go this way, it's higher at the top, lower at the bottom. Can I grind this shim according to Cessna? So when you buy the shim that they extort from you, or from the owner, okay, it's never going to fit it perfectly. So, okay, now it's going to be like that. Or if I flip it, well, I want to get more camber. I need a little more camber. Well, then it's going to go like that. Well, bummer. Now I didn't need it. Now I'm kind of still facing toe in. Well, now I got to get it towed out. Well, you buy a different one, and it says, well, put that one on there. Somebody's been bad on that one. Okay. Well, then we get a little smaller one. Okay. Now we can stack the bigger one. Well, I'm still 1 degree off. Oh well, that's how it's going to go. Okay. Yes, sir.
So then you just buy a whole stack of them?
Yeah. Like this stack here is beautiful. Here, I'll pass them around, and you can see just how different. What have I got? 5 or 6 here. I could pass all of them around, but just see how different each one of them is.
How much do those run normally?
Ooh, I don't remember now. They're outrageous. They're outrageous. But what's crazy is you're not going to get it. They even tell you, here, I'll show you the next page, but they're even going to tell you that you're going to get it good enough. That's about all you're going to get. Good enough.
Do they have tolerances for how many degrees it can be outside?
Yes, Cessna does. But in the fine print, it tells you basically you're never going to get it perfect. Either camber's going to be off or toe end's going to be off because of the way you rotate it. It doesn't go this way. It goes, what was it? $30 each. Okay, so thankfully you shouldn't have to do this too much unless they make a real hard landing. Okay? Yeah.
Do you have to jack it, check the toe,
Yes.
shim it, put it down?
He's jumping ahead of me now. Yes. So now I adjust it. Then I've got to pull it forward a good another 20 feet. Or you push it back and then pull it forward, whatever. Okay? Because the moment I go up and then set it back down, now the Cessna's sitting like this again. You got to get load effect on it. Okay? There we go. Okay? So some of you, none of you had wheel pants on your on the aircraft. Okay? You all already demolished your wheel pants and fixed them. But this here is a backer plate, usually for a wheel pant. So once you take an axle off, I don't know what it did with the axle. All right, so once you remove the axle, okay, please use a Sharpie and mark the direction, because you may have to take that on and off, on and off, on and off. But I've watched people forget to put that back on after they've got it cambered right or towed in. It's like, oh crap, we forgot the wheel pant bracket, which changes the toe in and toe out camber then. Oh no! So then they go ahead and slap that back on. This is a very common spot to crack. Okay, so this is why I'm telling you, because you may have to remove this. When you get a new one, it's going to be thicker than the one that has been worn for the last 30 years. Okay, so there's a good chance that if they do have wheel pants or wheel fairings on there and you replace it, the new one's going to be thicker. Okay, so you may have to start this process with the shims. So if you buy one of those, just already think, all right, I'm going to have to re-shim it and get it realigned. Okay. If they ever make a hard landing or you start to see corrosion on the axle, it's another time you may have to replace those. Okay. Any questions? Everybody good so far? Shimming. So it is a little bit frustrating with the Cessnas because you can't, especially if you're OCD, Leo, if you want it perfect, okay? Because, man, it really annoys me because I'm going to cheat one way or the other. Am I going to win with camber or am I going to win with toe in or toe out? Yep.
Maybe a hard landing, and then you have to think about changing those heads on the camber.
Yeah. And so we'll get into I think I already did that, special inspections, where you get into a special inspection where you have to go all right, I made a hard landing, they come to you and say, we need you to inspect basically your axle, you may even have to send it off for eddy current. Yeah.
And what is preferred? You can only cheat it so much, would you prefer towing?
Okay, that's what I was getting ready, that's my question, you're not supposed to ask that, Brian. So what would you prefer, toe in, toe out, or camber? Okay, here, let me show you a picture if you're still wondering what language I'm speaking. Okay, so toe in, you have, this is extreme, I get it. So let's say we're going down the runway. Now just remember, we're going to slightly pull on our tires. So we're gonna have a toe in the shop just slightly, so that this is extreme. Okay, toe in or toe out, okay? What would you think we would prefer on a Cessna? Would you more toe in, toe out, or more camber?
More toe in, toe out.
You want to focus on toe in, toe out. Why is that?
Flip the wheels.
You can flip the tire. You can flip the tire. You can take the wheel part and flip the tire. Hopefully deflate it first. But flip that, right? And that's not a hard job, okay? You do it pretty quick. As you do it, you get quicker and quicker with it. Any question, comment?
Parker does that with his car.
Yeah, 100%. You do it with your car. Yeah, absolutely. Aviation, we do it on a regular basis. If you catch it early, a pilot's going to say, "Please, good, yeah, save me $300. Pay you $80 or $100, or even the pilot, owner, operator is legally allowed to do that." Right? Okay. Any other questions, comments? Josh, you hanging in there, buddy? Yeah, somewhat. Okay, good. All right, here is the manual, okay? This answers John's question. Is there a tolerance? Yeah, there is. So, wheel alignment for flat spring, okay? Flat spring is the flat, like a 172, older 172s. Tubular, you get to a tubular where it's the round, like we do on the 210. The 172 XP had tubular too, correct? The one you had, the main was, those were
We
tubular.
had mine.
Yeah, yours was tubular, yeah. So, we have flat spring, camber is 3 to 5 degrees, and toe in is 0 to 0.6 inches, okay? So as you set your 90, your square on the ground, okay? You set the 90 on the ground like this, okay? Toe in, you're gonna check your camber this way and this way, okay? And you're gonna see what the distance is, okay? What's my camber? 3 to 5 degrees there. All right, and then tubular gear on the old ones is not adjustable, okay? But on some of the other ones, as I said, you'll shim it. Yep.
Which direction is that 3 to 5 degrees? I know it's the vertical camber, but is that like top in or is that top out?
I gotta go back and look. Typically, it's gonna be positive. If you go the other way, it's negative.
Gotta be top out.
The manuals, if you go to the next page in the manual, which I don't think I have it here. Let me see if I have it here. Ah, dude. Okay, you got a positive camber versus a negative camber. So positive, 3 to 5 degrees. Okay, and they're using a bubble protractor. I like a square, but whatever works. Okay, makes sense? Those of you who've done Cherokee, the older Cherokees do it in minutes, and I'll save that for the last day, so that maybe I don't put you all to sleep today on how to do the math at the very end on minutes. Yep.
That, .06, are they measuring that off the rim?
Yes, or off the furthest extent of the tire here. So you find a center point on each tire, because typically the tire is going to stick out further than the rim itself. Yeah. So you want to do it pretty close to the center, but if, in this case, your tire is probably going to stick out, so you do it across that. Okay? You don't want to do it up here, because this is where it's worn, but not, normally the sidewall should not be worn. Okay? There's no curbs in aviation. We don't roll over curbs. All right, let me go back one slide. Okay? Grease plates are a great idea. Okay? They're not mandatory, but they're a great idea. You can get a couple pieces of scrap aluminum, throw some grease between them, and then roll the aircraft up onto that to be able to check your camper. Okay, I kept saying square. Carpenter square here across the wheel is a good idea, and you'll be able to measure that distance. Okay, what the degrees for toe in and toe out. All right, general idea what we're looking at here.
Do you measure the camber going into out while it's on the ground? Because that's when you're going.
Affirmative.
The wheels are going to be.
Yep, but you want, as I said, you want to pull the aircraft forward from here to the back of the room. I had a video of me doing this, but I wasn't as exciting as the air tractor, because air tractors are just cool. Okay, so I'm going to show you the air tractor video instead of your short ball-headed instructor. Okay.
Hello, I'm Cody Dixon, flight line mechanic here at Air Tractor. Today we're going to show you how to measure your main wheel alignment on your airplane. The need for main wheel alignment is indicated by a number of subjective observations. The first probable sign of the need for alignment is excessive tire wear or feathering of the tread beads. Dog tracking, or the tendency of the airplane to crab during taxi and roll out after landing, is another sign of misalignment. Also, a visual observation of both wheels for symmetry of angle with respect to the airplane center line when viewed from the front may show a need for alignment. The tools we're going to need are blocks, cans, jack stands, a long straight edge, a measuring device, a protractor, and a 24-inch carpenter square. To check your alignment, the airplane needs to be full of fuel but with an empty hopper. Taxi or tow your airplane a short distance in a straight line to allow the gear legs to assume their natural position. This should be done on a flat, smooth surface, preferably on a paved surface. Toe in is measured by placing a straight edge across the front of the tires approximately at axle height. You can use anything that is readily available to hold your straight edge up, blocks, cans, or both. Today we're going to use jack stands. A 24-inch carpenter square is placed against the straight edge and the outside surface of the tire. Be sure to hold it level with the ground at axle height. Now measure the gap between the tire and square. The tire should be square or have up to 1/16 inch toe in at the highest point of the tire sidewall. Camber is measured by placing a protractor on the vertical axis of the wheel center. Camber should read 1 to 2 degrees. Repeat these steps for the opposite side. If your airplane fails this check and your operation isn't equipped to hoist the airplane, you will need to take it to an Air Tractor dealer or authorized service center to have your main wheel alignment adjusted. This concludes our video on how to check your main wheel alignment. If you have any questions, call your Air Tractor dealer or visit airtractor.com. Thanks for your business, and please fly safe.
Okay, so what did he say? How much toe in is preferred? Hey, she picked it up. 1/16. Why 1/16? Yeah, because typically, well, especially in an air tractor, you're gonna fill the hopper, to go spray. So when you start getting passengers in the aircraft, you're also going to load it as well. It's going to pull the tires back. So typically you want to toe in 1/16. It's dead on. You're going to have an issue as you start to wear down the runway. It's going to pull those tires out. Okay? Make sense? Everybody good? Short and sweet video. All right, you guys need a break, don't you? How about you come back at 10 after 9? Retractable landing gear. Sorry, my screen is turning red on me. No, one. You're done. There it goes. Okay. Retractable landing gear. Why do we need retractable landing gear? Speed. Okay? Because what do we notice with this type of aircraft? Oh, come on, it's slick. What do you notice about this aircraft? All kinds of drag, man. All right, look at it. It's just, no, there's no tire back here. Oh man, just a straight skid. Call it a plow, whatever you want to call it. Okay, we got, you know, boat anchors right here, boat anchor right there, and then lots of drag here, and then the attachment for here. Oh, and that's really aerodynamic there. All right, what type of drag is that? Parasitic. Who said that? Stick them up. Okay. Parasitic drag that opposes thrust and airframe and moves through the relative wind. It increases, parasitic drag increases as speed increases. Right? You got more pulling back on the aircraft because there's more to catch on, more drag. Things that add parasitic drag or types of parasitic drag, which, if you've noticed, this attaches to other classes, okay? So we're getting ready to get into flight controls. Flight controls is probably just as practical as this class, where this class is 75-25, where we're 75% shop, 25 classroom. And flight controls is just about that as well. It's probably 65-35, somewhere in there. So, other things that add drag: wing bracing, struts, landing gear, skin surface, rivets, rivet heads, and wings themselves all add parasitic drag. Okay? Where do we get the idea of landing gear, retractable landing gear? There we go. From a great designer, a creative designer, the blueprint. High and tight, tucked up, right? And so the chief engineer is where we get our engineering from. Okay? Oh, come on. There we go. Yeah.
Hey, Mavericks.
Yeah.
Hear about ice?
What's that?
You want another one?
Really?
I feel the need for speed. Ow!
Okay. So, what's the goal in retracting our landing gear? Speed. Speed. Less drag, speed. Get there quicker. Okay. So, what are the cons of owning a retractable landing gear?
Maintenance costs.
Maintenance costs. You're going to pay for it down longer, more complexity. Okay? When you leave here, you'll say, whoa, 414 was insanely complex. I've had 4 students from last year's class text me and say, I've worked on 414s this year. Okay? Highly complex. Adds weight, induced drag to the airframe. It limits options for safe runway usage. Okay? Why is that? That's right. You don't want to land in a bean field or cornfield. Okay? Requires additional training for the pilot. Call it a complex, right? Complex sign-off. There's an increased likelihood of malfunction. Just as your car is going to break down at some point, there's going to be a malfunction in the landing gear. Okay? There are safeties, but in reality, there is going to be a malfunction. Okay? I told you I've had coworkers leave just a few screws out, as little as 21 screws out, and the landing gear not come down. Okay? So those little baggies with screws left over after you're done is no good in aviation. Okay? Automotive world, we just throw them in the trash and hope we can't find the holes later. All right? It is highly expensive. Highly expensive. Okay? Retractable landing gear methods. How do we retract the landing gear? We get rearward retraction. Give me an aircraft with rearward retraction. A cardinal main gear. Cardinal main gear. Anyone else? Any others? Okay, 210. Yeah, same idea. Remember the one that I showed you where you had commanders? Good. DC-3. DC3 goes which way though? Forward. Okay? All right, sideward retraction. What about sideward retraction? What in the world? Huh? Full 14, main gear goes side, side, inside. Beach jet? Huh? Beach, okay, good. Okay, Corsair. Yeah. Forward retraction. 210 nose. Come on, Zach, you should have said that right off the bat. You and Joshua got well acquainted with the nose gear, right? Oh, you were going to say that. Okay, any other forward retraction? Forward retraction, any other forward retraction? Ask. Oh, mains, yeah, good. You caught me there for a second. Okay, upward retraction. And fibs. Any others? C-130, main gear. Boop. Straight up, straight back down on the main gear. I'll show you a picture in a second. Okay. Retracting landing gear, rearward, could be used on nose landing gear, tail gear, main alighting gear, okay? The disadvantage of this design is that the airflow could not be used as an aid. Okay, actually what does the airflow do? Prevents it from coming back down. Okay, in the event you need to extend it. Require backup pressure. What type of backup pressure might we have? Say it again. CO2. Nitrogen. Okay, may have an emergency hydraulic reservoir as well that would allow it to flow. Okay, this is a blessing. Last year they did hydraulics class after landing gear, and it was like a gong show. You knew what a gong show is? Anybody old enough to know what a gong show is? Like every time somebody said something dumb, they would hit the gong. Gong! Like, oh yeah, it was because you can't do landing gear without understanding hydraulic flow, and so you guys are light years ahead. It's super cool. So it makes hopefully everything go a little quicker. All right. Sideward retraction. Landing gear retracting inboard or outboard is used only on main landing gear. Right? You don't see the nose gear going whoop. A little awkward that way, okay? And not suitable to use on nose. Fuselage does not allow any nose gear or tail wheel to be retracted. I'm sure one of you is looking for it or thinking of it like there was somebody who made a dumb mistake. Some engineer that said, let's put the nose gear going sideways, and I'm going to prove Ryan wrong. That's fine. I'm here to be proven wrong. So, we have a small structure with the nose gear going up, electrical compartment, radar, etc. Out in front of the nose gear on the beach jet is all the avionics, okay? So they want to make as little impact as possible, so smaller nose gear on the beach jet, okay? Sideward retraction, okay? Bearcat, tail wheel retracts as well on the Bearcat. Okay, this one, DC3 also tail wheel retracts slightly up, even though it's exposed, still retracts. Okay, yes, we got. Okay, tell me what it is. Hawker, okay. Built from what years? 68 through 74, something like that. 109, you nailed it, dude. Nailed it. Okay, all right, great. So rarely will you see one with a nose gear for sideward retraction, okay? Forward retraction, generally used on both main landing gear or nose landing gear and main landing gear. Considerable effort required to retract. Lots of pressure to go up because it's against the airflow. Airflow acts as aids in assisting emergency extension because you really want the gear to come back down. That's a good thing. Yeah, that's good. Okay. have DC3, boom, gear goes up, the honk and landing gear. Over on the left side, even bigger, right? I've never seen one on float. Sure would like to see it.
Is that a different model where tail doesn't come up?
I'm sure they had to remove it.
No on the other.
Oh, there, I wonder if it's just slightly retract, so it's not full. Because normally your tail wheel will still stick out. It only goes up about 8 inches or so. Yeah, and then that one over there, totally modified. All right, problems with retract gear on a float plane. Okay. Let's do it again. No, he didn't. He had no idea.
I'm surprised they made it down.
Say what?
I'm surprised they made it down.
Yeah, I know. Okay, so we have considerable issues with landing gear. Okay, all of you at some point, if you're in aviation, are going to see a landing gear failure. Okay. You're going to watch the pilot. They got busy, was in an ILS holding pattern, or they were in a hold for 10 minutes, and then as they turn inbound, okay, they get cleared to land, turn inbound, all of a sudden they forget landing gear because now they've been so frustrated with ATC that they forget to put their landing gear because they've just been sitting there turning and turning and turning and turning, okay? Or, I told you, I'm not sure if I told you, sorry. But a friend of ours came in, I don't know how many thousands of hours he had in a twin. Comes in, and sure enough, small airport, uncontrolled, was thinking about having to use the restroom, because he'd been flying for 4 hours. He's like, man, I gotta make a pit stop. Forgets to put the gear down. He was in a hurry. So, sure enough, forgets to put the gear down, didn't realize it till he's about six or 7 inches above the ground. It's like, why am I not touching? I'm floating and floating and floating. Okay. So upward retracting. The alighting gear is retracting upwards into the fuselage. See that? Pretty cool. Retracting landing gear into the wings is not a viable option. Can you imagine landing gear coming down on those wings? Boom! Oleo struts that were 5,000 pounds apiece, right? Mainly used on high-wing aircraft such as the C-130. Okay. Those of you going to Oshkosh this year, you have an opportunity to be able to see a lot of the bigger airplanes, KC-135, C-130s. If you ever have an opportunity to go to the Dayton Air Force or Museum of the Air Force, it's free, 100% free. It's really hard to see it in the day. We've done it with students, so we've just taken off. There's a campground close by. I think they charge us about $10 a night, and we've done it. Really hard to do in a day, though. All right. The gutless cutlass. The gutless cutlass. Okay. We've got a 172 RG or R182. It's 172 RG or R182 or 210. They all retract kind of the same way. The nose goes up, forward, and the mains go backwards, okay? In my experience, you will see most of those aircraft or these aircraft without gear doors on the mains. You will not see gear doors most of the time because there were so many problems with the main gear doors hanging up, okay? And it's already fighting to come against the airflow. So majority of the aircraft, I probably haven't seen but maybe 3 or 4 with gear doors still installed in the last 20 years. they leave the nose gear doors on for obvious reasons. Because you'd have a giant air catcher right there the whole time. So the nose gears are staying on still. Okay? Anybody flown a 172 RG or R182 or 210s, anything like that? Okay, yeah. Cardinal, the same thing, yeah, without Cardinals, without strut here. Yeah. Sorry, I made a dig at 172, but I won't say it right now. Okay. What did I say? It's like the epitome of absolute minimum amount of horsepower to lift an airframe, incorporating retractable landing gear. Okay, you get one person of fuel, maybe the instructor. Okay. All right. Retracting method, system of retraction. So we have mechanical type, a mechanical type of landing gear. Okay. Give me an aircraft with mechanical type and tell me why it's mechanical.
There's like Vikings or whatever, right?
Okay, Belanca Viking or Moonies? Belanca Viking.
Yeah.
Viking was made by Belanca, yep.
I don't remember.
All right, what do you mean by mechanical?
It's like pulleys, isn't it?
Yeah, so you've got this cute little handle that looks like a flap handle, but it's your gear. Ka-choo, back up and back down. Moonies, they love it. Straight up, straight down. That's all it is. Just a cool little lever that looks like an ejection lever. It's really just a mechanical landing gear. Gear goes up, gear goes down. Super nice, but it's got to be made from a very light landing gear. You don't see them doing that with oleo struts. They're actually the rubber pucks because you got a little bitty steel rod in there. You just pick it up, boom, gear goes up. Then we have electrical type. What's an electrical example of electrical type landing gear? 414, 340s, 310s, 411s, 421s with the hydraulic. But what is it doing? How does it do it? Well, it's using an electrical motor with push-pull tubes, and they run the length, sometimes 30 or 40 feet of push-pull tubes, back and forth. Okay, so not that would ever have any problems, right? So in 1979, Cessna said, you know what, we should probably go to hydraulic. It's a lot easier to put lines, and they dropped the weight of the landing gear and increased the load so they could actually carry another person by going to a hydraulic landing gear on the twin Cessnas. So we have hydraulic types, 210s, right? Sometimes they're electro-hydraulic. What does that mean? Hydraulic motor running the system, but then they're using hydraulic pressure or fluid to actuate with the actuators themselves. But also micro switches that turn them off and on. That's also part of the system. Okay, even all the way up to the throttle. So as I told you back in my early days, one of the cool things was to put the gear handle up as you're pulling out onto the runway. And so as you start to taxi out and then you're like clear to take off, you put the gear handle up, throw the coals to the firewall there, and then as you start to float down the runway, you get about that far off the ground and the gear goes boom, up, and then you would just hold it right there and then take away. Well, the problem is now you hit a sinker right over the runway, and then you get a little bit of clean riveting on the bottom there. Okay, shave all the rivets off the bottom of the airplane. And so Piper realized that in the 60s people thought that was cool, so they put a horn at the firewall to make sure you knew that you needed to throttle all the way to the firewall. Okay, so there's another micro switch there. Pneumatic landing gear. Okay, they don't use pneumatic, thankfully, anymore as the main source of landing gear. Any problems with that? Compresses, anything else? It's really hard to see if there's a leak. Imagine bringing you into the shop and it's like, how do you know if 5606 is leaking? It's everywhere. You start touching it, it's sticky, it's literally everywhere. Oh, if it's sticky and it's in the belly, it's the landing gear or the brakes. Versus pneumatic, it's like, man, I got no idea what's wrong with it. You just like a vacuum leak in a car. Dude, let's just drive it. You know, because you can't find it after a while. You get annoyed. Imagine if mechanics said that about your landing gear. Just leave the gear down. We can't figure out where the leak's at. So you can't really do that. So pneumatic, we're using CO2 as emergency, or you'll use nitrogen to help blow down the gear. Okay. Retractable landing gear also provide with mechanical locks. We want to hold the gear up because the air is not always smooth, and lock it securely in the event that we hit sinkers or it gets. Imagine if the gear broke loose every time they would hit turbulent air. Boom! Gear comes down. So devices to indicate to the crew about the position of each undercarriage. That gets a little tricky over the last 40 or 50 years, where it would tell you, oh, gears up, gears down, or gears in transition. At first, they would just tell you if the gear was in transition, and there would be no light to indicate if the gear was up. Okay? Then we went back to where the gear's up, and get a light, and then the gear's down to have a light. Okay? Means by which the landing gear can be extended in the event of a hydraulic or electrical power source failure. Okay? So we want to be able to have a means to get the gear down. Means to prevent retraction when the aircraft is on the ground. What is that called? Squat switch. Squat switch. Okay? So this year we're going to be able to test the squat switch the correct way, as I've already fumed about the one student who tried to do it while it was sitting on the ground. Okay? Don't test it while it's on the ground. Okay? It's a $30,000 mistake. Don't do it. Okay? Means to guard against landing with the landing gear retracted. Okay? What is a normal means? Those of you pilots in here, what's a normal means of telling us, hey, your gear is still up, dummy? You have a horn, okay? Sometimes we have an audible voice. Gear warning, right? Any others?
Sometimes it just drops it, doesn't it?
Good. Piper just says, hey, dummy, you're slow. And the moment the airspeed falls to a certain level, and you put the gear handles down, poof, blow down, okay? Diaphragm type. Man, that will scare you if you're doing slow maneuvers. Okay, pull it down, pull the gear handle back, throttle handle back, and you're just slowing down, nice and slow, and then all of a sudden, boom, falls down. Scare you. Okay? You have what was I talking about here? Why did I switch this? Oh, okay. All right, so I think the big thing with the trunnion bearing surface here, so you had a trunnion on yours, right, that was bent at the top for the steering on the nose gear, Leo, and Lee's not here. Okay, so it's not uncommon to have a trunnion steering mechanism at the top. Here, we need to have a hinge point, okay? Or what we would call, this is a terrible illustration, what we call an over-center bar, okay? What is the purpose of an over-center bar, Nate? What do you think? You want the bar to go over-center. You want it to go over-center in the event that the pilot makes a hard landing, okay? So that the gear does not collapse, okay? On the beach jet, it has a removable linkage, okay? Sometimes you'll have a linkage right at that bar. So I put a note in here, please remember to put the safety back in, okay? Everybody clear there? Make sure you put the safety back in. In the event that we forget to, it might not retract, okay? This is a typical electromechanical system. This is one you're going to see this year, okay? Let's work through this gently, okay? I'm not going to get into the adjustments because I feel like it's pretty in depth. Okay, so here is what? What do you recognize right off the bat? Strut. The type of strut specifically. Oleo strut. Good. So we have an oleo strut, and then somewhere in the middle here, we're going to have the bell crank assembly. Bell crank assembly. A used bell crank today for a full 14 is $1,000. That's no motor. That's only the bell crank. Okay? The motor is another $800 used. About a $4,000 set. Okay? And it actually uses a very, very, very small motor. Okay? And the motor has the ability to go either direction. Okay? And so what happens is, as you turn the gear handle comes down, it will turn a giant bell crank, pulling and pushing two rods to bring the gear up. Okay? So there's an insane amount of torque underneath. Then you have these rods from here to here. Then they go into what we call another bell crank assembly that will turn. And the bar will turn to pull, to use that leverage to get this gear to unlock. So here's your over center bar. Pulls up, okay, breaks over, and the gear will come up into the wheel well. Everyone clear? Somewhat clear? I know we're not yet super clear.
Does that bell crank have to be big enough that the rods don't hit each other?
Yep, and you have to have enough clearance. Here's the difficulty, Parker, with that is when we start measuring it right here and you say, okay, it's off, the gear goes up too high. Okay, what would be a problem, Dan, if the gear goes up too high? Hits the aircraft, okay? You're going to see one when you're doing an inspection this year that went up too high and put a hole in the bottom of a wheel well, okay? So it goes up too high. So then we start adjusting, Parker. We start adjusting it. Now we say, well, we need to come out half turn. Well, the way the manual tells you is you basically, if you start changing here, you have to change it all the way back. So you do a small turn here, small turn here, small turn here, small turn here, all the way out. Okay? Because the common problem is if this gets in a bind, right here, this rod gets in a bind, the whole gear is not coming down. All right? That's why they went to a hydraulic landing gear later on. You didn't have that potential. If a hook caught, normally they could use nitrogen to overcome that. Okay? One of the things that we have, now, word of warning, just as disassembling a wheel or an oleo strut will, blow your face off, an over-center bar will take your fingers and not give them back. Okay, and it's quite large when it comes over center. It's usually about 3 to 4 inches, and it breaks over. Okay, and it's normally the pressure right here is about 50 pounds. Okay, holding that gear down. And so once we break that bar over, this right here, there's a good chance it could, if you're not paying attention, could catch your arm, clothing, ear, hair. I've seen it. Okay, so part of our test is we do a spring scale on this to know the amount of pressure pulling it back. Okay, so we jack the aircraft and we pull against that spring lock, because once the gear gets to right here, we want it to pull and lock in and not come undone. Okay, so we do a spring test with that, and we also do a drop test on the landing gear, where you break it over and you pull it to a certain amount of inches and you let go to make sure the spring is going to pull it into place every time. And so it's a big thud, boom, boom. And we're checking that when the landing gear gets to a certain point, maybe it's right here, that the spring will do the rest of the work. It will pull it down the rest of the way. Okay? That's in the event that the arm didn't go quite far enough. You should have enough spring pressure to pull it over. Any questions on this diagram right off the bat, right here? The cool thing is when we're doing this, the giveaways for us are the spring pressure here, okay, and the drop off. So you have a spring pressure, you'll do the drop test, and then what we call the drop off, where the gear goes all the way up into the wheel well and then sets back down. Okay? And so if the gear runs that full length back and forth, usually that will be a dead giveaway that this rigging is correct. Okay? A typical re-rig job of a 414 takes somewhere about 12 hours for 2 people. 24 hours. Okay? What type of system is this? Electro-hydraulic system. So we've got a reservoir, we've got a filter, we've got a gear type pump. Okay? The gear is reversible. You run it one way, we get pressure. Okay? We're going to push it. Which way is the pressure running right now? We're pushing the gear down. Okay? We're pushing the gear down. We typically have more volume pushing on the top of those pistons to push the gear down. Okay? Then we turn it, gear goes up. Change the gear handle, gear goes up, pushing on the pistons, pushing the gear up. How does it hold the gear up? Does the gear just stay there because of hydraulic pressure?
Doesn't the air up, like, it's got the pressure regulator, and then once it gets below, 2,000 psi or something, it kicks the pump on?
It does, but it also has a series of hooks that's supposed to hold it. It's supposed to hold it in place, okay? But those hooks are also hydraulically actuated, like a 210 or a Cardinal 177. They have hooks that have pressure there. Now the hooks oftentimes have accumulators on them to make sure that they don't lose pressure too quickly. Okay, you don't want to unhook while you're flying along, and then you got gear falling down because you had a little less pressure. Okay.
What makes that a hydraulic electric? Because of the pump?
You have an electric pump. You also have micro switches, but heads up, most of the time, most people would not consider a micro switch necessarily making it a electro hydraulic system. It's electro because of the electric pump.
So it's just an engine-driven pump?
Yeah, if you had an engine-driven pump.
Hydraulics.
Yeah, but you have some form of backup.
Right.
In this case, it might be a CO2. Sounds pretty rough in there, didn't it? Okay. All right. So here's another type of system here. We've got door actuators now added to the equation. So if we have door actuators, what needs to happen? What do we need to add in the system then? Sequencing valve. Boy, you guys are light years ahead of trying to explain this to somebody who's not seen it before. So you have a gear door sequence valve that says, hey, your gear door is not open. And so it will tell the gear not to run yet. This was the problem on the 210s and 177s, why the main gear door got basically removed. Okay. And so then you'll have a gear door lock. 210s, on our 210 you'll have a gear lock at the top and a gear lock at the bottom to hold them both in place. Okay.
So were there ADs to rear the gear doors? Or discretion?
No, there was not AD. A service bulletin came out that you could remove them under certain cases. When we did that, you had to remove certain accumulators, part of the hydraulic system then. And of course the sequence valve. Yeah. But you're still leaving the gear doors on the front of the aircraft, which they also changed some of those over to mechanical linkage. I think Zach had it. You guys don't remember? If you had, they would just have, when the gear comes up, it's going to hit a lever to close the door.
Yeah, it's like kind of like a turnbuckle in a way. It's like as the gear drops, then the doors go with it, but it comes up
Yeah, and so they went away from the gear doors that way by using mechanical linkage in. Yeah, and that was a service bulletin on that. Okay, all right, let's do some Corsair. Red Bull. Sorry for the music, I didn't do it.
There's 1, 2. Fix 1, 2, 3, throw turning nostril. And then this is getting tight. This ends together. This ends together.
Okay, notice that you have an actuator here. Just a monstrous assembly here. Okay, but here's our spring. You actually have 2 springs pulling on it. Okay, and then over center. So here and here. Okay, holding that so that in the event you have a hard landing, should hold it from collapsing on the gear. Okay. What is this? Polio strut. Is that low pressure, mid pressure, high pressure?
High pressure.
High pressure. How do you know it's a high pressure? Fitting. Tube. Nailed it. Nailed it, dude. Good job. You have the 2, okay, but it has a larger nut right here as well. See, this one's larger than the bottom. It's a very high pressure. Yes, sir.
So I noticed that the guy, like it came down or whatever by itself, but then at the end he had to pump it a little bit. I thought that the job of that spring was to do that because you said that if you like kind of push it up a little bit, it's supposed to come down. So is that considered like a pass? Like you have to like pump it more instead of like actually push it down?
Sure. He's probably just, that one's a hydraulic system. It's not electro system.
So that
It's
spring.
a hydraulic. He's just probably finishing off the last of the pressure for the locks to go in and hold it there. Okay. Versus electronic system, when it gets to a certain point, electromechanical, is it's going to finish off that pull just to make sure it holds it. Versus this one, the hydraulic pressure is going to hold it, push into a lock. He's going to press in the lock. If the lock failed, that spring should still hold. Yeah. Good. Any questions? Everybody okay so far? You guys are doing well. I know it's a lot of stuff. A lot of stuff going on. Okay. All right. So electromechanical. This is our 414 setup. Okay. Common twin Cessna system. Okay. Here's your bell crank assembly, and the cute little back of this one is the motor itself. Okay. So you're in the cockpit. You put the gear handle up. It's going to run a motor. What tells that motor when to stop and when to start? Limit switches. But they run the limit switches right here on top of the bell crank, not down here. Okay, so this is going to run till it hits a micro switch. And it works like, man, I cannot think of the word, Brian. The bell crank itself works on a huge, I mean, it's about that big around, okay, maybe about 10 inches. And it's going to actually pull this rod this way, and it's going to pull this one. So it's going to turn the top of that bell crank this way to pull that gear up. Now, the nose gear is actually on the bottom side of that bell crank. You can't usually see it. Sometimes they were designed to, like a worm gear, just to spin, okay? And some of them actually force that landing gear back, okay? When the nose gear is up and locked, you'll hear it pop. It's like a 70-pound pop. Boom! To what we call a snap over. This will actually let the gear go down, okay? And so as you're flying along, it's got 70 pounds of tension on a spring holding that gear up. Yeah.
How is that bell crank big enough that, is it really only like 180 feet before it's locked?
It's less than that. They only turn about 120 degrees before the gear gets up.
Is that why that crank has got such a big...
It's quite large, but then you also, they call this the bell crank. This is a lopsided, the bar's about that big, and it has an arm on it like this. We'll look at it. But it has an arm on it like this, and as it turns, it's offset. So this lever here, so it comes here and here, and because of its offset, it should pull the gear up within 120 degrees turn of that bell crank. So it is your job to make sure that when you put the gear handle up, that these are perfectly rigged so that the gear goes up. It actually, an electromechanical actually pulls the gear up and then sets it back down in the wheel well. About an 1/8-inch drop. It pulls the gear all the way up till it hits and then drops it back down so that it's holding it. Okay? What's actually holding it is these rods the whole time. It's crazy. Okay? And if any of those are off, even a 1/2 inch, the gear may not come down. All right? What do you notice here? This is 414. Oh, it is dirty. It's been loved and abused, okay? But what else do you notice from this type of landing gear? This electromechanical. What do you... My issue is when you get out in the shop, most of the time you're like, no, I don't know what I'm supposed to do, right? But what do you recognize right off the bat? What are
a spring?
Okay, you do see a spring. Do you see the spring? There's a spring, yeah, right there. You got a spring for the lock. Yep. What else do you notice? What do you recognize? Okay. You may recognize an oleo strut. Big. Let's start big. Oleo strut. What do we recognize next? You said it, Zach. Over center bar. Okay. All right. And this locks it in the rest of the way. You already said the spring. What do you think that might be? Micro switch. That's your micro switch telling you that the gear's down a lot. Okay. Indicates in the cockpit, hey, the gear's locked. Okay. That is a left gear, left main gear. In the cockpit, you've got something like this. Okay, you'll have a up landing gear and down landing gear. And as I've told you once or twice already, it's one of my scariest things in the 414 or in any of the twin Cessnas. Some engineer decided that they would put the gear handle where? Right where you get in the cockpit every single time. Okay? The 210s later on, they were really wise. They put them on the co-pilot, but slightly higher. But the twin Cessnas were notorious for getting bumped, and then you kick the master on and the gear goes up because the micro switch or the squat switch wasn't working. Okay? So part of our job is we have to check that the micro switch actually or the squat switch actually works. You should have a horn. Moment you put the gear handle up on accident, okay? Now, color codes have changed over the years. There's no standard, okay? It's like the screws that we have, you know, there's not really a standard order for screws, okay? So a green means good, down and locked. Amber would mean, if you have a 3-color code system, that is slow down, okay, or go faster. No, it means that in transit, gear is in transit, okay? As I told you, there were some aircraft that used the yellow light to tell you that the gear was up. I guess that's caution? I don't know. But red, what is a red usually indicated of? Unsafe condition. Gears up or in transit as well. Sometimes it would say it's in transit. Okay? All right. Down and up. Okay? Usually it's just down. You get 3 greens. Okay? Down. Okay? In transit is your amber color. Amber, orange, amber, whatever, yellowish orange. Sometimes, as I said, would show that it's in the up position. And then not locked, or that it's up. But there were several aircraft that gave you no light at all in the up position. Okay, I didn't really like that. I want to know that the gear's up, but there were some aircraft that had no light at all. Okay, two light system, no light in transit, and then up. All right.
Is it true that, like, you know how most of them, you have like this like 3 down and lock, you know? But you always have to have 3 individual lights for each gear, or could it just be 1 green, 1 amber, 1 red, but then if it's red, you don't know.
So what was the issue when they did just 1 green light for all the gear?
When you don't know it, well, like, if one's down and the other one isn't, would it say that it's green?
No, it shouldn't. Okay, that was a series system where all the stars had to align, where all 3 gear had to be down. That was a series system. But the problem is you didn't know which gear it was. Okay? So that's why typically the 3 green lights, it's a little bit safer. You can at least know, okay, all 3 gear are down and locked. Okay? I've heard some crazy stories about airplanes coming over and mechanics pulling nose gear down after it's not locked all the way down. A little bit crazy. Even Pilatuses that try to land and pull the nose gear down while they're landing. Okay. So where do we get the idea or the rules for the road of how we inspect landing gear? Where do we get that idea? So what? Trevor, you gonna guess? AC 4313, okay? AC 4313 and the maintenance manual. Hey, before I get AC 4313, take a break. Guys, come back to 10 after.
Does that mean like both were not locked in transit and not locked? Like
Yeah,
over center?
it's in danger. Yeah, they're not up, they're not locked.
So then the green, that could be
Down and locked.
down or up, or not. Meaning like,
You usually get an amber light.
isn't that transition?
Not
Sorry,
always.
sorry, I'm talking about like, if it's down